Hello everyone, welcome to Everyday Lead Code. This is Tirth Doshi and today we are going to solve another problem called as non-overlapping intervals. So what is the input, what is the output? Let's just go with the logic of the problem, the structure of the problem. So the structure of the problem is that you are given a vector of vector or you are given a matrix and every matrix or every vector of vector you are given intervals. Okay, and you need to find the minimum number of intervals that you need to remove so that all the other intervals would be non-overlapping. So that's the question out here. If we just understand the question a little more through the examples, let's look at the first example. Okay, if I look at this example, this particular example, there is a 1 2, there is 2 3. Okay, so imagine these intervals as the lines. So imagine 1 2 as 1 comma 2, line in a 2D geometry, in a 1D actually, the number line. Okay, anyways, then you have 2 comma 3. So 2 to 3 is somewhere here. 3 to 4 would be starting from the 3 and going till the 4, and 1 to 3 would range in somewhere in between. So that is the thing. So which interval will I remove so that all the other intervals become non-overlapping? So I can remove a 1 comma 3 so that 1 comma 2, 2 comma 3, 3 comma 4, all of them are under non-overlapping. So I can do that. So I remove only one over here, one interval, that is 1 comma 3, and I get all the other intervals to be non-overlapping. Similarly, if I remove a 3 4, what happens? If I remove a 3 4, 1 comma 2 is there, 2 comma 3 is there, 1 comma 3 is there, so they are all still they are still overlapping, since 1 comma 3 is overlapping with both of these intervals. So then I remove, because I have removed 3 4, I would have to remove, let's say I do not decide to remove this 1 3, I decide to remove 1 comma 2, then I decide to remove a 2 comma 3, and 1 comma 3 is remaining. So 1 comma 3, still it's the condition that I have got all the intervals that are non-overlapping in the set, but the number of intervals that I required to remove were higher than 1. So the question is that I want to get the minimum number of intervals I need to remove so that all the intervals in the set are non-overlapping. I know that if you have a 2 over here and if you have a 2 over here, although the boundaries match, they are not called as overlapping intervals. Similarly, if you have 3 over here and 3 over here, the boundaries match, they are not called as overlapping intervals. Okay, so if you have 1 2 1 2 1 2, I can remove any of the two 1 2s, 1 comma 2, and I can say that because I removed the 2, the third one is non-overlapping with uh, any of the other intervals in the set. So if you have a 1 2 and a 2 3, so imagine a 1 2 over here and a 2 3 over here. Since both of them do not overlap, do I need to even remove any of the intervals? No, I do not need to remove. Because I do not need to remove, I say that the output over here is 0. Okay, so now how do I go about solving this problem? Now, approaching this problem itself is the main thing, So the approach over here should be, in fact, it can be used anywhere. We take simple examples, and after taking these simple examples, we move on to more complicated examples and check what should be the output logically by our mind. We do not do anything related to coding first. What we do is we just think about taking a very simple example. The very simplest example we can take is, we can take only one interval. So if you had only one interval, 2 comma 4, it's not going to overlap with anything else. So if it is not going to overlap with anything else, I even need to remove any of the interval? No, I do not need to remove any interval, and that's why the output would be 0. Similarly, now I process, but getting that 0, my mind processed that thing very well, fast. But going step by step, the computer needs to process that what my mind is processing first. So I need to code it in such a way that the computer processes it. Okay. Then another example that I take is, I have an interval 1 to 4. Okay. I have an interval 3 to 5 somewhere from here, and I have another interval 4 to 8. So 1 to 4, 3 to 5, and here the 4 to 8 will be. So this would be one interval, this would be another, and somewhere here the third interval. So I can make it, in fact, 1, let's just say 1 to 4 is something like this, 3 to 5 is something like this, and then a 4 to 8 would be something like this. So if I remove this interval, I can say that these two intervals would be non-overlapping, and therefore the output should be 1. What if I try to remove the 4-8? If I try to remove the 4-8, these two intervals would be overlapping, and thus I'll need to remove the 3-5 as well. So two removals. If I remove the 1-4, okay, if I remove the 1-4, that means 3 and 5 are there, 3-5 and 4-8 are there, they are overlapping. So I need to remove any one from these also. So again the output would be 2, but the minimum is 1. So that's why the output would be 1. Now, okay, so let's go about thinking the pseudocode for this. Okay, pseudocode. Now, I know that over here, if you see, the outputs are like, the input itself is pretty sorted in its own way, as in the last point. So if you see, the last points are in ascending order. Even the first points are in the ascending order in this example. So the inputs were pretty sorted. So what I will try to think about is, let's just randomly think that I visit every interval in the array. So I visit a 1-4, I visit a 3-5. The moment I visit a 3-5, I check if it is overlapping with my previous interval. So 1-4, oh, it is overlapping, so I just remove this guy. Then this is kept here, and 4-8, I check with my previous if it is overlapping. Is it overlapping? Answer is no, it's not overlapping. So I can come out of the loop, and since I removed 1, I would output 1. So that is how I want to think about it. Now, since the input can be in any fashion, of course, like 1-4, I took an example where this came first, but input can be in any fashion. The first thing I need to do is pre-process it, and I need to pre-process such that pre-process and sort the input. This should be my pseudocode first. I'm not thinking about how will I sort it. I can have two options: sort by the start, or sort by the end. If you go about thinking, how did I do this? So I compared 3-5 if it was overlapping. So compare the current interval with the previous non-overlapping uh, previous interval, and check if they overlap. If they do, remove the current interval, okay, and increase your count or whatever. and finally output the number of removals that you did. So it's a pretty greedy approach. So we are locally choosing that 3,5 without thinking about the previous thing. So that means that in a greedy approach, there is always a pre-processing generally required. So that's why we have pre-processed and sorted the interval. Now we are thinking that what should we do? Should we sort it by the start, or should we sort it by the end? Now let's say I decide to sort by the start. Okay, so you have 4 and then 1,000. Then I check the second interval is 5,6. So they are overlapping. So I remove this guy. Next, I check 6 and 7. Are they overlapping with this? Yes, overlapping. So I remove this guy. Then I check again 7,8 is overlapping with 4,000. Yes, I remove it. So this was sorting by the end. But start. But if I sort by my end, okay, so 5,6 will come here. In the same example, 6,7 will come here, and 7,8. So when I sorted by the start, I saw that there were 3 removals. But when I sort it by the end, I check 6,7. Is it overlapping with 5,6? Answer is no. Then I check 7,8. Is it overlapping with 6,7? Answer is no. So I do not do anything. 4,000. Is it overlapping with 7,8? Yes, it is overlapping. So I remove this guy and say that there is only one removal. That means by thinking about both the directions, I came to the conclusion that, okay, I'm going to sort it by the end. So sort by the end, then I will compare the current interval and the previous interval. How do I compare it? I will take these two intervals, these two pair of intervals, and I will simply check if the starting point of the second, okay, is lesser than the ending point of the first. If it is true, if the starting point is somewhere here and ending point of the first is somewhere here, then I will say that these two are overlapping intervals, because I'm sure that the starting and the end point would always be higher. So anyways, that's how you check if it is overlapping or non-overlapping. Okay, so that's how we approach it. Now what we can do is we can just look at the code. After looking at the pseudocode, so we know what the pseudocode is. So generally what we do is the first step is pre-processing. So I've just pre-processed it. Pre-processing, sorting it. I have these intervals and I sort it by the end. Okay, this comparative function simply sorts things by the end. So it takes a vector A and a vector B, that would be 1 2 and a 2 3, for example. It will, if the second values, that means A of 1 and B of 1, if they happen to be equal, then I sort it by the first value. Else I generally just take the last value, that is the end values 2 and 3. I will compare them and I will say that whichever one is smaller will come first. So that's about the comparative function. Here the count is simply the number of intervals that I am going to remove. So initially the count has to be equal to 0, and the last valid interval, so I do not explicitly remove it from the array, but I just keep a pointer that is the last valid interval. Okay, so for an example, when I removed, so for example, in any example, if I remove a 3,5 over here, I'm not really removing 3,5. I'm just saying that the last valid index should be the index of 4,8. That's what I'm going to do. Now, that's the last valid interval variable. Now, if integer I is equal to 1 to the size of the interval, if the interval of the current interval and the previous interval, the last valid interval, it's the last valid interval has to be 0 initially. If they overlap, for example, in this case 1,4 and 3,5, they overlapped. How do I know they overlapped? I made a new function called as overlaps. The start pointer of the first is lesser than the end pointer. So by interval of I, it's the right this thing. So that's the right interval, and this one is the left interval of last valid interval. So this A is actually the I plus 1th index in general. Not this I, but this is the previous index. So I will compare the start. Yeah, I will compare the start of this guy, the start of this guy with the end of this guy. If the end of this guy is higher than the start of this guy, that is this, then I return a true saying that they overlap. So if they overlap, I increment the count and I do not do anything for the last valid interval, because if they overlap, the last valid interval was this guy, so it still remains this. Then if they do not overlap, for example 4,8 comes here and 1,4, I check, they do not overlap, then the last valid interval comes at I. So we'll just walk through this example itself. Walk through. So anyways, the pre-processing, that is the sorting, has been done. Now I is equal to 1. When I is 1, what happens? And last valid index is 0. What happens? I is 1, valid index. Are 1,4 and 3,5 overlapping? Yes, overlapping. Okay. So what happens to the count? Count becomes equal to 1. Okay. What happens to the last valid index? It does not change. In the next, I is equal to 2. Last valid index is still a 0. What happens to the count? 4,8 and 1,4. Do they overlap? They do not overlap. They do not overlap. So what happens to the last valid index? The last valid index becomes 2. That is equal to I, which is equal to 2. Okay. So then I come out of the loop, and what do I return? I return my count, saying that count is equal to 1 as of now. So I return count and I return 1 over here. And this is how I got 1 as the output. So that's how you approach it. So in general, I would just say that whenever you see a interval problem, try to think about a greedy approach. Maybe there is some sorting required. Generally, the sorting happens through the endpoints. A lot of these problems are similar. So, and when you start thinking, just randomly think about this one approach, try it out, make small solutions, and so on. Yeah. So that's the way to approach these kind of problems. And yeah, you should walk through an example to even understand this better. So that's it for today. Have a great day, guys.